Okay, because I done signed up for some Zoom. I don't know what it is.
I'm going to ask you guys if you could, and if you haven't already, to please go ahead and just mute yourselves so that we don't have just the background noise. But good evening, everyone. Thank you guys for joining us tonight. It's great to see all of your faces. I see some of you kind of in and out, but it's good to see you. I'm Chantel Harrison. I'm the NPHC president here in Tampa. I'm a member of Delta Sigma Theta Sorority Incorporated, Tampa Alumni Chapter. I think I have some of my executive board on. Tamisha, I do see you. So if you could pop in and introduce yourself.
Hey guys, good evening. Thanks for joining us. My name is Tamisha Van. I am the NPHC treasurer, and I am here with all of my Greek friends, but specifically on behalf of Zeta Phi Beta Sorority Incorporated.
Thank you. And is there anybody else from the exec board? Rob, did you get a chance to get on? If not, Robert Winters is the vice president, and we have Jamie Kibler, that is our secretary for NPHC. Everyone on here, thank you guys for joining in tonight. Definitely appreciate you. There are a lot of people on, so it's good to see you. We definitely thank you guys for just connecting with us to get this information out to the community. We're going to be talking about what We Care will be discussing COVID in the African American community. Dr. Hill, I'm going to let you go ahead and take over. Dr. Hill is the program director for We Care, so I'm going to go ahead and give you the floor.
Well, good evening, and thank you so much, Sarah Harrison, for the one introduction, but secondly, the opportunity, and definitely would like to acknowledge all of our Greek fraternities and sororities. It's just such a pleasure to be able to host you all. So as Sarah Harrison mentioned, I'm the program director for We Care, but I'm a professor and associate dean of clinical affairs for the Tanasia College of Pharmacy at University of South Florida. And for the past nearly 10 years, I've been able to serve in that capacity. And so tonight you get a chance to interface with our community-based entity, which is called We Care. And so this evening, we have our core team available. You'll be hearing from our illustrious dean a little later. He'll be the feature presenter, but I wanted to introduce Dr. Deborah Austin, who is truly our primary community partner, and we are grateful to her and Mr. Michael Morgan for pulling together the coordination of the program from a technological standpoint, but also being our foundational partner in these kind of ventures. You'll get a chance to appreciate all the things that We Care has done, and this is just one of many examples of how we are trying to make a difference in closing health disparities in diverse communities like ours. And so We Care takes pride in partnerships with all community entities. And so we are just so excited to have all of you here tonight. So you will get a chance to appreciate, some will refer to him as my boss or my supervisor, but I refer to him more affectionately as a colleague, as a mentor, and as a friend. And that is in the person of Dr. Kevin Sneed, who is the brainchild of We Care. He also is the founding dean for the Tanasia College of Pharmacy, a practitioner of approaching almost 30 years, but he has been in the Tampa Bay community for the last 20 plus years, and at University of South Florida as an ambulatory care specialist, providing services to patients with a lot of chronic disorders, ranging from diabetes and hypertension, hyperlipidemia, anticoagulation, and not. He is a product of Xavier's College of Pharmacy, but he has a bachelor's degree in microbiology. And so we'll be fortunate tonight to appreciate that background, because he'll be sharing a lot of pearls on the COVID vaccine and other aspects. And so you could appreciate why we wanted to have the workshop tonight and have you appreciate the insights that he has. Dr. Sneed is probably one of the most read clinicians in the Tampa Bay area, if not the state of Florida. He has been following all things related to COVID, the infection, and certainly the vaccine since the start of the pandemic. I think he is somewhere near over 300 articles that he's read, and this probably numbers close to about 30 presentations and workshops that we have done since June, trying to be a pivotal point for the community as a trusted resource in relation to making sure that we can help dispel so many of the myths that are out there and the misinformation that's going on related to the pandemic, and particularly how we're going to rebound from that. We all know that African Americans typically become the target of disorders, health disorders in general, but certainly COVID has affected us in a deleterious way. And so we are doing this program and others to try to make sure that we can bridge the gap of information and help make sure that people can make an educated decision about things related to treatment and prevention in relation to COVID, based on getting it from a trusted source like Dr. Sneed. So I would like to introduce him to some and present to others. Dr. Sneed, our dean, as well as the executive director of We Care and founder for the organization. So Dr. Sneed, we'll let you take it from there.
Dr. Hill, thank you very much. I'm really appreciative always for you and your very kind introduction. For our community partner here, Deborah Austin, I can't thank you enough for everything, for the partnership. We've been pushing now for about 2, maybe going on 3 years. And so the relationship between We Care and Reach Up is not new. And I also want to give greetings to Ms. Chantel Harrison, the president for the local chapter for NPHC. In full disclosure, I just want to make sure everybody knows up front, I am a member of Kappa Alpha Psi, Fall 87 initiate, and also Sigma Pi Phi, the Boule. But this evening, as I told Dr. Hill earlier, we're going to go completely agnostic because tonight we're going to share information that many of you hopefully will really listen to. We're going to leave enough time at the end for a question and answer. And please, if you have an opportunity, put your questions into the chat. I hope it's a very entertaining presentation for you. And so we're going to go ahead and get started. Oh, one more thing. I would be remiss if I did not mention our other team member, Mr. Hiram Green, who is not present with us tonight. But he is no less one of the most integral people, and to be 6 feet 6 inches, he's a big giant teddy bear, to be perfectly honest, and I love him to death. And so I just wanted to make sure we mentioned him. So I'm going to share my screen here, and we will get started. Okay, Dr. Hill, can you confirm that you can see that for me?
Yes, sir, I can see it perfectly.
Okay. All right, there we go. Okay, and to start off with this evening, we wanted to entertain you all hot off the press. I mean, I'm talking like maybe 10 o'clock this morning. We have an introduction here with We Care. We Care stands for the Work Group Enhancing Community Advocacy and Research Engagement. It started with an NIH grant that I was a part of starting back in 2008 with a partnership with Moffitt Cancer Center and USF Health. And it's the only living project. And so Dr. Hill has joined us as our program director. And we have a video that we'd like to introduce to you all this evening. Why do we care? Why we care? Why this program? We want to improve health outcomes.
The collaboration between USF Health's Tanasia College of Pharmacy's We Care program and Reach Up Incorporated aims to bridge the gap between underserved communities and access to care. We Care's mission is to increase the representation of diverse populations in clinical research. It starts with rebuilding trust between academic and clinical institutions through educating and empowering the community, and then providing research opportunities along with protection and advocacy for the participants.
They want to hear the story from folks who have been through a clinical trial. You have to share all of that information with everybody.
So take the opportunity to have a better quality of life in our communities. Join us.
As I mentioned before, that's hot off the press this morning. So Dr. Hill, you did wonderful putting that together. So tonight we're going to talk about the coronavirus and this whole, what we call the SARS-CoV-2. And so just to make sure everybody's aware, even though we're in the middle of a pandemic and we're watching a lot of bad news every evening, the coronavirus is not new. Initially, there were 4 types that we knew of, and they commonly caused the common cold and in some cases the flu. Many people, when they thought they had the flu, actually about 10% of people actually had a coronavirus that caused very similar symptoms. Many of you remember the original SARS outbreak that occurred about in 2002. And then a couple, about 10 years after that, we had the MERS outbreak, which was also a coronavirus. And of course, now we're dealing with the novel coronavirus, or again, as I'm going to refer to it as SARS-CoV-2 or COVID-19. Now you can see on the far right, we had on the far right here that it took about 10 years to go from the original SARS to MERS. And now we've gone from 10 years down to 7 years with the next version of the coronavirus. And so if we keep on that same trajectory, there's a great possibility that we may have another outbreak in another 4 to 5 years. So we just want to keep that in mind that this is the same family of viruses. I'm going to show you a video here just to kind of acclimate many of you to what this virus is and kind of give you a sense that yes, it is real. In this animation, the great part about the antibodies that are produced in the body, we're going to spend a great deal of time talking about it. So what you're looking at right now is an actual photograph. It's an electron microscopy photograph of a single cell from a body, and the yellow specks on there are actually the coronavirus. So when we're talking about millions of copies being produced in the body, and I'll show you exactly in a moment how that occurs, the first thing I want to make sure that everybody's aware of that, yes, it is a very real virus and it does exist. Now, just for animation purposes, they added color here to so that we can see the difference, but we want to share that with you. Now, these are also electron microscope pictures of the virus. And you can see on the outside, the spike proteins, and the spike protein is really important for us to really grasp a hold of. So I want you to implant that in your brain. But the spike protein kind of resembles the corona on the sun, and hence the name coronavirus. Now, many people in the very beginning, starting back in about April, began wondering and asking whether or not the coronavirus and COVID-19 was man-made or was it bioterrorism. Well, we want to share with you this evening that from the very beginning, scientists across the world were able to genotype the coronavirus, the COVID-19 virus. And it's a version of what we would call almost like 23andMe. They did a genetic family tree of it. And as you can see, we actually have been able to detect when and where it actually mutated. And so all indicators are that right now, no, it is not man-made. It actually did mutate out in the wild and then escape and jump over to human beings. Now we have additional information that kind of confirms that. And so what you're looking at is how, people want to know, well, how do we know so much about it? Again, here on the very bottom, we've been able to take very, very clear images of the coronavirus and elucidate exactly when, where, how, and why it mutated in exactly which animals. Now, many of you have already seen this particular photograph of the coronavirus. On the red spikes are the target for what we are trying to do in terms of vaccine production. That also is a very important component for how the virus gets into your body and then winds up infecting your body. So one of the other challenges that we need to be aware of is the fact that one of the new unique components of this particular virus, in the human being, we have a receptor that is all over the body, and I'll show you exactly where they are in just a moment. But that red spike attaches onto this receptor in your body. It's called the ACE2 receptor. And when it makes that attachment, that's how it gains entry into the various cells in your body, and then it replicates there. But the thing about it, the ACE2 receptor is so ubiquitous and it's spread so far throughout the body that it allows the virus to attack many different organs in a way that many other viruses just are not able to do. Now, in this particular cartoon, I've only put it in for a couple of reasons. Number one, I wanted to show that when the spike protein attaches onto that receptor, and you see that here on the far left, when it does get into your body, it begins to unravel, and then it grabs proteins from your body, and then it repackages itself, but not just as one single virus, but as many multiples and hundreds of viruses from that single cell. Eventually, that replication process winds up killing that individual cell, causing further damage. Now, what you see highlighted in yellow are the various medications that we initially tried to use, because quite honestly, we had never seen this particular virus before, and we were just grabbing for any and all medications that we thought may be effective. Right in the middle, you see the word hydroxychloroquine. We've all heard about that medication. The reason people honed in on that is because we found that back in 2005, it was believed that there may be activity against the original SARS, although with COVID-19, it hasn't been nearly as effective. So one of the main things I really want to share with all of you is the fact that, yes, it is primarily a respiratory virus, but for people that have what we call chronic conditions, chronic health conditions. So if you have diabetes or if you have high blood pressure, for those that fall into the category of being overweight or having obesity, those that have asthma, when you have these chronic conditions, that kind of sets in a total environment of inflammation inside of your body. Now, it's really important to understand that for the uninfected individual, and if you don't have those conditions, then you're probably not going to have any symptoms at all. If you do have diabetes or any one of the chronic conditions I mentioned, right there in the middle, you begin to already have what we call inflammatory proteins, inflammation that is inherent to you having that condition. On the far right, when you see the coronavirus come in, and if you have a very uncontrolled condition, now we're setting up what we call the cytokine storm. And that cytokine storm produces a large amount of these inflammatory proteins. And when they begin to spin out of control, it kind of makes a lot of bad things happen inside of your body and various organs of the body. And so you can see many of the symptoms that begin to result from that infection. Again, the fever and cough are the things that we really expect. But if you have more of these conditions, and if you have uncontrolled diabetes and uncontrolled high blood pressure, you can see that there are many other things, including respiratory failure, that begin to occur after that. Now, the coronavirus, this current COVID-19, it can affect many different organ systems in the body. I've often told Dr. Hill that I couldn't believe that when I really began reading about it back starting on March 3rd, about a month later, I realized that we really had not ever seen a virus do exactly what this is capable of doing. It can affect so many different organ systems in the body, unlike other respiratory viruses. So even though we talked about early on people having respiratory failure, we began to realize pretty quickly that it was affecting many other organ systems in the body. And so on the far left, you see the word neurological. And so yes, headaches are one of those. But then we also have people that have, and you all may have known people that also had a loss of taste or smell. Individuals that wind up having these headaches. Early on, we found people that had acute kidney injury. Down on the very bottom of the lower left, we had people that developed diarrhea. This was one of the early symptoms that we really began to try and hone in on. Now, other viruses can cause diarrhea, but this seemed to be a little bit different than what we had seen before and much more prevalent. But then all of a sudden, when it got into the general larger population here in America, that's when we started seeing many of the things on the far right that concerned us even more. When you see the word thromboembolism, and that means that you've developed a clot that can travel. And so now we were watching people develop clots in very abnormal places, and even what we call microclots were forming inside of organs. And then also the cardiac conditions that we were really concerned about, especially for people that already had chronic conditions like diabetes or high blood pressure. And so they were developing heart attacks or inflammation of the heart tissue. Now that ACE2 receptor I talked about, you can see here exactly how diffuse it is throughout the entire body. It does have presence in the heart and in the lungs and in the intestinal tract. Now, we don't understand all the way, we don't find ACE2 receptors in the brain, but we know that the interface between the brain and the rest of the body, there must be some association because of the neurological component of what's happening. And so this truly is a very serious virus that we're dealing with. So now I'm going to show another animation here that kind of explains a little bit more about how the virus itself gets into a cell in your body and then the body's response to that.
In a world where millions of lives are under threat due to COVID-19, it is of vital importance to gain a better understanding of how the virus actually works in search of a cure. The surface of the virus particle is covered with approximately 100 spike proteins. They always come in groups of 3, in which the proteins are intertwined. Each individual protein consists of 2 parts: a globular head called S1 and a stalk-like structure called S2. One of the 3 heads is slightly bent, enabling it to connect to the so-called ACE2 receptor on a human cell. Once the connection between the virus and the receptor has been established, the human body activates the TMPRSS2 enzyme. This is a protein-cutting enzyme that proceeds to cut off the head of the spike protein. This causes a change in the structure of the virus. The S2 protein now grows longer, penetrating the human cell. The protein then retracts again, bringing the membranes of the virus and the cell very close to one another. At this point, the virus can enter the cell through a process of endocytosis. It engulfs the cell with its membrane. The virus has successfully invaded the cell and can now start to multiply, ready to overrun the system. However, we have strong defense mechanisms that try to prevent this from happening at all costs. Scientists recently discovered how our antibodies react. It's actually a very simple process. Our antibodies bind to the spike head, or S1, thereby preventing it from connecting with the ACE2 receptor and stopping the virus from spreading. Understanding exactly how this process takes place is key to the rapid development of a vaccine, making it an essential part of our ongoing fight against this global public health crisis.
So now I'm going to get a little bit more into the conversation about vaccines. Many of us are hearing much about vaccines in the news, and so I wanted to give you all as much information as I could about that. Now, one of the things I really wanted to share with you, what you're looking at here, and this is a little bit complicated, but I'll take you through it very quickly. When individuals actually become infected initially, they really don't know they've been infected, and they probably don't have any initial symptoms early on. But not long after that, we can detect it probably in about the first week. So about day 3 to 5, we can actually detect that you've had it. And so if any of you have had that swab in your nose, we can begin to detect the virus and its replication pattern at that point. Now, the next thing that begins to occur is the fact that now that you've been infected, you see the purple and then the green line here. That's about the time that your body really does begin to try and mount a robust antibody response to it. And so those 2 lines represent the beginning of antibodies forming in your body. And so we're beginning to believe that from the time that an individual probably has been exposed until they really begin building very serious antibodies is probably about a 10-day period. Now, there's a lot of variation in who that can occur in, and some people are going to be much more robust and early on in the beginning. Some people may not have as much of a robust response in building antibodies after they've been infected. And there's a whole other a whole other component of the immune system known as T cells that we're not even going to discuss this evening. But we do understand that people who have had prior exposure to some level of coronavirus probably also have T cell immunity, and thereby they may be able to ward off that initial infection. But this does begin to explain why so many people succumb to the virus so early on. And so the vaccines that have been developed, and I just want to take a moment and let you know that there are over 200 entities between universities and corporations all around the world that are in vaccine development of some sort, and of those 200, about 40 have moved into some level of clinical trials. Of those, I'm just listing about 5 of them here. And the ones in green are the one that we've heard the most about most recently, and are probably going to have emergency use authorization occurring beginning next week. And so these 2 companies, and let me just share that with you. When you do a clinical trial, unlike other vaccines, these particular vaccines have been very robust in how they were done. You can see here between at the very top, the University of Oxford and AstraZeneca clinical trial going all the way to the bottom. We're probably at a point of having close to about 150,000 people around the entire world that have been at some level of clinical trial with a vaccine. From
the air conditioner on down here.
If we could have someone mute there, it'd be very, very helpful. And so with these particular companies, I want to let all of you know that we've had about over 200,000 people who have gone through clinical trials all around the world. And as you have gone through the clinical trials, we have not had one single individual die because of a vaccine that was administered. I'm going to talk more about that in just a moment. And I'm going to very quickly, just for time's sake, I'm going to go through this very quickly, but I want to help everybody understand how these vaccines work. So once an individual gets vaccinated, it's actually going to go through, and then the ones from Moderna and Pfizer, the ones that are coming out here before the end of the year, they work with technology known as messenger RNA. And so what they have been able to do is to code and take the genetic code of a portion of the coronavirus right there in that green box, and they've been able to kind of replicate it. But they've only taken the part that replicates the spike protein, those red spikes on the outside, and then they take that RNA strand and then they actually duplicate it, and then that's what gets injected into the body. And so instead of forming the entire virus, now the only thing that's going to form are going to be the red spike proteins, which are impossible and completely incapable of having a person get infected with coronavirus. And it's very important to understand that when that does begin to occur, that now your body has an opportunity to recognize that a foreign body is inside of the body, and it will begin forming antibodies against those spike proteins. Now, it's a very important thing to understand. We're going to show a video here, and just, I guess, let me just show the video very quickly. It's very quick, and I'll talk through it. There's no sound here. When your body begins to have these antibodies form from the vaccine, it's now like preparing an army against the fact that you may become infected with the actual virus, what we call the wild type virus, out in the community. But you've already built antibodies and you have them waiting so that if you do come into contact and you are infected with it, that the antibodies will attach onto it, they will attack it and neutralize it before it has an opportunity to really form any problems for you, hopefully not form any problems for you, and not have you succumb to any of the bad effects that we showed earlier. Now, the big question coming up is whether or not the vaccine seems to have been produced way too quickly. And I understand exactly why people are concerned about that, but I want to share some information with you that you're probably not hearing in the general news cycles. I'm not going to go through all the wording here, but the rapid development of the vaccine actually happened because we've been studying this technology and studying this particular virus for a long time. To be perfectly honest, the people at University of Oxford actually began developing a vaccine back in 2005 in response to the original SARS. But when the original SARS went away, there was no need for them to continue at the same pace of developing a vaccine against the coronavirus. However, let me just share this with you, that new technology has come along, this messenger RNA. And so people are thinking, well, we woke up on April 1 of this year and all of a sudden we want to come up and try this brand new vaccine. Well, it's not true. Here, if you take a look, you can see in 2013, this company was actually awarded a grant of $25 million. And I'm going to show you in a moment where the $25 million came from. They awarded it to a company to begin doing even more research to advance what they were already doing in terms of development of messenger RNA vaccines. So now this article came out back in August, and it was at a hearing. And the hearing was a congressman by the name of Bill Foster. They really began explaining exactly how we got this technology and got it done so quickly. And what the general public doesn't know is that President Obama and his administration, in response to the Ebola virus, actually commissioned this company to go out and begin doing messenger RNA vaccine research. Now, it's really important to understand that after 2013 and then 2014, when they actually commissioned it, more money came in to develop it in 2015. So this messenger RNA that's coming out from both Pfizer and from Moderna, it did not start this year. This technology has been around for probably an 8-year period. But the whole idea was that we knew, and he knew, and the whole team back then realized that we needed something very quickly. We needed to be able to respond very quickly in case a new pandemic came along. So here at the very bottom, Project Warp Speed and current efforts to produce an effective COVID-19 vaccine as quickly as possible would not be finding success if that had not happened in 2013 and 2014. Now, I was able to go back and find a speech that President Obama gave back in 2014 in response to Ebola and the need for vaccine development. Again, I don't want to read the entire thing here, but I've highlighted exactly what he told the group that day. If and when a new strain of flu, like the Spanish flu, crops up 5 years from now, and it's not, interestingly enough, this was 2014, and we're talking about coronavirus 2019, so he was almost spot on. 5 years from now or a decade from now, we've made the investment and we're further along to be able to catch it. It is a smart investment. It is not just insurance. It is knowing that down the road, we're going to continue to have problems like this. Okay, so he knew, and we knew a long time ago that this was going to be a possibility. So you can begin to see that through the messenger RNA technology, back in 2013, again in 2016, it got more funding. We all may remember the Zika virus that was harming fetus and baby development in pregnant mothers. Well, they actually took the technology and formed a vaccine for Zika. But Zika went away fairly quickly, and so they never had an opportunity really to put it on the market. But I would like to share with you that they have actually developed it, and they actually have very similar results, much like what we're seeing right now with the current vaccine on the market for coronavirus. So now, in terms of oversight, people are really concerned. There's no oversight. Well, that's not true either. Just wanted to share with you that the National Medical Association, which is primarily the Black doctors from around the country, they formed a task force to be able to engage directly with the FDA and the pharmaceutical companies. And the whole idea behind that was to make sure that we had oversight both for people of color, for African Americans, for those Latinos, and everybody else, to make sure that everything they were doing was going to be fair and transparent and equitable. I've had an opportunity to speak to this gentleman here, Dr. Leon McDougall. He's at Ohio State University, and he's the president of the National Medical Association. And we've had some wonderful conversations about their oversight and the role and the information that they've been able to get from the FDA that's not readily apparent from the rest of readily apparent to the rest of America. Now, many of you may have heard that there were problems with some of the clinical trials. Yes, indeed, we acknowledge that, but I'd like to share with you here one individual out of all the people who have been tested around the world, about 200,000 people at least. We don't know how many people were tested in China or Russia, and I don't have a number for that this evening. But the only individual that we feel may have had some level of harm in a clinical trial was during this study in Johnson & Johnson, but we're not sure that the vaccine caused that problem. Earlier, so the thing I would like to just share with all of you is that when you see a pause in a clinical trial, that means that the oversight mechanism is working. It doesn't mean that there's anything necessarily wrong. It just means that the people who are charged with doing oversight of that vaccine production and the clinical trial are actually doing their job, and they pause everything to make sure about safety and efficacy of the vaccine. You all may have heard that one individual did die during the clinical trial, but we found out that individual had the placebo and did not actually have the vaccine. And they died of a stroke, and so they just had the health condition that unfortunately had that person succumb. And so the other thing that we've been working on is making sure that there was equitable distribution for all people. And so the National Academies of Medicine came up with a 4-phase strategy for how they were going to try and distribute the vaccines when they came out. And so now we're all watching phase 1 unfold right now. Again, we want to jumpstart with the high risk and first responders. And also we want to make sure that people that work in hospitals, like physicians, respiratory therapists, even the EMTs, the emergency medical transport individuals, that they get the vaccine first because they're coming into constant contact. One thing I have been pushing for and pushing as many organizations as possible is to include essential workers in that, which very often does include many people of color. You see here in phase 2, now we're talking about teachers and everybody else that may be involved. And so there's been talk that teachers are probably going to be moved up. And so when we talk about communities of color, and this is really what has driven me for the past 6 months now, nationwide, African Americans are dying at a rate, in this case, at the time I pulled this article, it was 2.3 times the rate of our Caucasian counterparts. Those who are Hispanic or American Indian, they were dying at 1.5 times the rate. So there was a disproportionate number of people of color that were actually dying once they became infected. Now, more recently, we've seen an outbreak in the Midwest where you have populations that have 85 to 90% white people. So now we're finding that the rate is going from 2.5 down to 2.3. Now we're just at 2 times the rate, but it still means that we're dying at twice the rate of our white counterparts. And so when we begin to talk about it, also, let me just share this with you very quickly. Let me go back here. When I pulled this information back in October, 41,500 African Americans had died from COVID-19 from available information. And when I pulled this on the 1st of December, 47,000 African Americans had died across the country. Now, let me go past that and get here just to speed along, because I really do want to get to a Q&A here. We do find that African Americans in every state were disproportionately affected above our white counterparts. Now, it's not, I want to be very clear when I make this comment to you. It's not because of anything that's genetic. But what we do find is that because of health disparities and health inequities, more people of color, and in particular African Americans, are more likely to have those chronic conditions I talked about earlier. Much more likely to have uncontrolled diabetes, much more likely to have uncontrolled high blood pressure. And therefore, when we became infected, we were the ones that were more susceptible to having challenges. I would also like to mention here that if you're a person of color and you go into a hospital, we were 4.7 times more likely to die once we arrived in the hospital than our white counterparts. Now, very early on, back in April, I wrote an article, I published it, and it wasn't really hard to determine exactly where the coronavirus and where many of the COVID-19 deaths were going to occur. On the far left here, you begin to see what we call the hotspots for cardiovascular diseases. And you see really dark areas right across the Sun Belt, beginning in the east part of Texas, extending into Louisiana, Mississippi, and Alabama, and up into other areas. And then when you looked at the early outbreaks of coronavirus and where the most cases were occurring, if you overlap these two, you found that they were overlapping in areas of people of color. And so to kind of wrap things up here, and in just a moment, I'm going to turn everything over to Dr. Hill, but I kind of bring you back to, once again, making sure that everybody understands this particular virus is dangerous. Okay, many people, I know there's been this kind of general myth that, oh, it's just, it's like the flu, or I've known somebody, they barely had any effect. Yes, there are people that have that, but I have had many patients. And I'll tell you about 2 of them very quickly. I've had patients that, I had a family of 4 that everybody in the household got infected, and each one of the 4 people had a different part of their body affected. So we cannot predict who and what is going to happen for individuals. The second story I would tell you that's really sad, and I had a chance to talk to this individual last week, one of my diabetic patients that we were treating. Early on, he became infected. And by the way, he had well-controlled diabetes, but he became infected. He had not one single symptom. A month later, he tested negative, and he went back to work. And then all of a sudden, he had an onslaught of various conditions associated with the coronavirus, and is now completely debilitated, and he's on disability. He cannot go to work. And the other thing is the depression that is set in, both from the coronavirus itself and from the fact that he can't live a quality of life that he had before because he really loved being at his job. And so I'm going to turn everything over here to Dr. Hill just very briefly to talk about We Care and really begin to explain why we wanted to really hone in on the Divine Nine sororities and fraternities and build a partnership between We Care and many of you present here tonight. Dr. Hill?
Well, thank you, Dr. Sneed, for that wealth of information, and I hope that everyone could appreciate that some of the information we're hearing on television, on the radio, and places, doesn't necessarily get down to the details that Dr. Sneed brought up this evening. But more importantly, we are just making sure that you are able to appreciate getting this information from people who are in it and designed to help you. So going back to We Care's mission, the reason that we care is primarily because we want to make sure that we bridge the gap of understanding with individuals like yourself who are in the community, our grandparents, our children, our colleagues, etc., with researchers and academics who are in pursuit of trying to find cures for disorders like COVID. And as you know, University of South Florida is a Research One institution, and we have since the start of the pandemic, there has just been a large effort towards COVID-related research. And there have been at least 30, if not 35 proposals that were funded by the university from university funds that are targeting us trying to find a cure and other ways to support, the impact of the disease. So one of the things that We Care is trying to do is really expand, engage, and empower the community with information such as what you got this evening from Dr. Sneed. And this is one of a series of talks that we plan to do. We hope that next steps will be a pivotal source for the community in understanding how to deal with some of the residuals and complications of COVID, particularly focusing on mental health. We also plan to, in the spring, to offer a workshop that will be explaining a little bit more about the Tuskegee experience and the story behind Henrietta Lacks, so people can hear the true facts about not only where we were during those times when, unfortunately, the African American community was really negatively impacted, but certainly how the processes associated with research have evolved so that we can truly protect people as they contemplate participating in research trials and have an assurance that researchers have no underlying motive, but that there are things in place to make sure that if you in fact endure any complications and things of that nature, you will be protected. And so those are some of the things that we pride ourselves on. We're also partnering not only with organizations like Reach Up, but certainly working with our faith-based community. Some of the workshops we've done in the last few months, we've included various groups from the faith-based community also sharing the same story. We're also working with national groups like 50 Hoops, who also are taking on the banner of educating the public regarding cancer and its impact. And so we definitely, that's another area that we're working with, and we're working with Moffitt and other local entities that are sharing that same mission. So we just really want you to know that if you get emails from us in the future about upcoming workshops, we want you to be ambassadors for us and to share this message that, one, we are a trusted source for information related to chronic diseases and disorders, but more importantly, we want you to understand the opportunities that we have in terms of research participation. And I really hope that you recognize that even though we've had so much work put into the COVID research, when it comes to this vaccination, we've only had about 3% representation from the African American population. And one of the things that we're going to really need to know is what to expect from this vaccine once it's available to the public. And the only way we're going to find out about it is participating in research. We don't want to learn after the fact, which a lot of times is what happens. And so again, allow us to help you understand more about the processes. And so that if you have questions, we just want you to know that you can always come to us. So what I'd like to do is invite you now to ask questions of Dr. Sneed, utilizing the chat. And please put your questions in there. And we have already captured your emails and other information, so that if we don't get to all of the questions this evening, we'll make sure that we reach out to you after the workshop. We also have a survey that will give us some feedback from you regarding the quality of the workshop this evening, and also to give us some insight in terms of whether or not you want more information on this and other topics, as well as some other things related to research participation. So if you would please be so kind as to do that, we would appreciate that. And I do see we have one or two questions, but I want to give you all a few seconds to put some more questions in the chat. But in the meantime, while we're waiting on all of you to put some questions in, I want to kind of do a roll call, because we have, I think, a total of 75 individuals on tonight. And so I wanted to appreciate where the representation is coming from. I know Sarah, Chantel, and myself introduced ourselves as members of Delta Sigma Theta from the Tallahassee Alumni Chapter, but I would love for all of you, if you want to certainly use the chat to tell us where you're from, and also what chapters you're affiliated with. That would be nice. And if you want to just very shortly unmute yourself as I do a little roll call, so we can appreciate everyone's that's here. Let's have a little fun while you're getting your questions together. So I will start out with the Deltas and see how many Saras we have with us this evening. So if you're available, just kind of turn your camera on momentarily and just take a wave so that we can all appreciate you all looking beautiful. Saras, so good to see you. So good to see you. Awesome, awesome. And then I know we have our sister sorority, the Alpha, AKAs. I mean, so if you're on, turn your mics off momentarily, or send us that Zoom wave. I see a few of you. Thank you. Awesome. Great. Great.
Hello.
Hello.
Sarah, everybody.
Hello, everyone. Hi. And then I know we have some sisters from Sigma Gamma Rho. Where are you? Turn on your camera so we can all see you. And I think we may have about 3 pages full of participants. So make sure that you're looking so you can appreciate everyone.
Hello.
There, sure.
Awesome. And what about our Zetas? Any? I see a few hands. Awesome. Great. Well, we are just so glad to have all of you representing us. Do we have any members from the Iota Phi Theta? Awesome. Okay, great. I'm seeing cameras and stuff go on and off. I can't tell, but give us some waves. No, well, let's move on then. What about the Kappas? Dr. Sneed was doing a great job representing earlier. So let's see how many of you are out here. I see a few faces I recognize. Great. And then let's move on to our
What would you eat?
Any Omegas in the house this evening? No? Okay, I don't think I see any of them. All right. What about some Sigmas? I know I saw a few names of a few Sigma brothers on here.
Yeah.
Awesome. Very good. Very good. Great. And did I leave out our Alphas?
Alpha's in the house.
Our Alphas are here. Wonderful. Well, we are just so excited to have all of you. And this is an opportunity for us certainly to join ranks and certainly helping share the message. And what I would again encourage all of you to consider is thinking about ways within our chapters that we can help both with the educating our community as well as giving people assurance about some of the information that is out there. And knowing where to look for information is really, really key. So it looks like we do have several questions. So what I would like to do is invite Dr. Austin as well as Sarah Harrison to kind of help me go through the chat, and we'll ask questions and allow Dr. Sneed to answer them accordingly. And don't forget, if you haven't already, to also complete the survey. So I'll start off with the first question from Purcell Jackson. Was there any evidence from the messenger RNA vaccines of the research you presented that those pieces of messenger RNA that were given could negatively affect any patient's genetic code? For example, how HIV can cause patients to be more susceptible to certain cancers in the late stage of the disease?
That's a great question. Let me be very clear about the messenger RNA technology. It has no capability whatsoever of affecting any other organ. The way I try and describe messenger RNA to many of our students is the fact that I want each one of you to think about the fact if you had a 3D printer in your house, okay, because now you can have a 3D printer in your house and you had a computer right next to it. When you communicate and you type in to the computer what you want the 3D printer to print up for you, there's a computer code that will go from the computer to that printer. Or you can even think about a printer, maybe the old dot matrix printer that will go back and forth. That is what messenger RNA does. It is nothing but a code that goes and tells the body what type of protein to develop. Messenger RNA happens to be what tells your body or how your body produces the cartilage in your eyeball, which is very spongy, which is far different from the nail on your finger. And your body is coded through RNA to be able to do that. And so to answer the question, Purcell Jackson, no, the spike protein cannot cause a problem. The messenger RNA cannot affect your DNA. It has no capability of doing it. And the reason that I've been looking at the messenger RNA technology for several years now, the reason I'm really high on it is the very simple fact that it gets into the body, it creates something, and then the body degrades it and gets rid of it. And by the way, your body does that for messenger RNA all day, every day while you're alive. Okay, it degrades very quickly. And so, and the comment about HIV, that really has much more to do with the immune system actually going in and now not having the capability of fighting off cells with T cells and natural killer cells, much more so than the fact that the actual HIV virus was the one that caused the cancer. So that's a very good question to get us started tonight. And I want to encourage all of you to ask as many questions as you can. And if for any reason, if I don't know the answer, I'll let you know. But I think Dr. Austin and Dr. Hill, I think I have a pretty good batting average so far over about 30 talks, right?
Yeah, he's been doing really, really good. Awesome. Well, I also wanted to just send a shout out to my Sarah from North Carolina. Wow. And we have people from Lakeland and all over Tallahassee, St. Petersburg, etc. So thank you all for putting this information in the chat. So I was looking for another question.
I see a question here from Jasmine Dumas.
Okay, yeah, Jasmine Dumas.
Jasmine says, what does the research say about vaccinating those who already had COVID-19? I think that's going to be one of the real beauties initially between the Pfizer product and the Moderna product. It really, in a way, doesn't matter if you've had COVID-19 before, because the spike protein that is going to form because of the vaccine will actually only produce the spike protein, and the vaccine, if you've already had, if you've already had COVID-19, the antibodies in your body are going to go and attack whatever the vaccine has done anyway. It doesn't have the capability of over-revving your immune system. So, the current recommendation right now, and I've been watching and communicating with people actually all over the country, and right now we're all feeling that even if you had COVID-19, if you had it within a 90-day period, you probably don't need to get the vaccine. But anything beyond a 90-day period, we're going to encourage people to go out and get revaccinated. and it should not cause a problem.
Okay. Very good. Thank you. Thank you. Mary Lindsay Barber wanted to know if the vaccine would be available for children.
That's another great question. I just had a meeting today with our chair of our pediatrics department. We are about to start a clinical trial here at USF, for which I have signed on to be a co-investigator for that clinical trial in children. As of right now, no clinical trial has been done in anybody under the age of 18, and we do not have information, or nor will it be approved anytime soon for pediatric use. So we don't have the information just yet, but now that we have a lot of safety data coming out from the current clinical trials, we are now going to begin bringing pediatrics into the clinical trials to make sure we can get them protected as well.
Thank you. Dr. Sneed, another protected group would be pregnant women, and Rosalind Connolly wanted to know what about using the vaccine in pregnant women, and then we'll go back to a second question from Ms. Lindsay.
I'm in a Zoom meeting too.
You know, that's a very good question. As of right now, one of the exclusion criteria was pregnancy. So I don't have any firm data to give you on that as of right now. And we really do need to get that data simply because, you know, even this week, nationally, we had an individual, and I do believe she was African American, that had to have a C-section with twins. Right before they took her, they successfully retrieved the babies, and then they turned her right around and they put her on a ventilator. Okay, so she was having that level of respiratory distress. But right now, I'm not aware of any clinical trials around the world that have actually vaccinated pregnant women at this current time. But I will tell you what will probably wind up happening along the way during the vaccination phase, not just now, but well into next year. There will be an opportunity for women who are pregnant to get vaccinated very often because they're not aware that they were pregnant at the time of vaccination. And then we will find that out. And then once we find that out, they will go and we will follow them and follow the natural course of everything happening with those individuals. So just to make sure, but we have not enrolled anybody in any clinical trials that were pregnant. Great question.
Yes. So Dr. Sneed, one of the questions that commonly gets asked that Mrs. Lindsay Barber wanted answered was, how long will the protection last from the vaccine?
We haven't had a good opportunity. It hasn't been long enough for us really to answer the question, although I will begin to tell you that the current thinking and the current scientific thinking, and one that I personally agree with on a professional level, is that it should, for a bare minimum, it should last for about a 6-month period. Now, we should all probably get in the mindset that we're probably going to have annual vaccinations, our annual coronavirus vaccination. And we should probably kind of get prepared for that. But there is data now beginning to come out that once you get vaccinated and you build that antibody, we are going to build what we call a memory antibody response in your body. And what that will allow you to do, that if you come into contact with the coronavirus again, it will begin to rev up, and almost like calling up the National Guard. You know, with the National Guard, you know, they're just living their day, you know, right around in the community. But when they get called up, it's like calling up the Army. And so you will have your own National Guard within your body in terms of antibodies to be able to go in and effectively, hopefully, fight off the infected, the infection of the coronavirus that has insulted you. So we don't fully have an answer for that right now, but stay tuned. But I do believe that anywhere from 6 to 12 months out should be pretty adequate for the initial vaccines.
And I think that question, came about. We had several that were concerned about the fact that the antibodies are good for about 90 days. And so, that's
I think it's a little bit longer than that. I think we're finding out now, and let me, Dr. Hill, let me share with our audience tonight that, we began clinical trials back in April. And anytime you enroll in any one of the clinical trials, they're going to follow you for a 2-year period. Okay, and so during that 2-year period, we're going to answer a lot more questions. But people that were vaccinated back in April, even today, now currently are still showing to have antibody production within their testing. And so, we're getting closer to that answer of the longevity of the antibodies from the vaccines more and more.
Mhm. So in people that have like renal and hepatic failure or liver failure, we have one participant that's concerned because their child has it. You know, what are the recommendations related to the vaccine use in those kind of individuals?
Yeah, my current recommendation right now would be definitely to get either the Pfizer or the Moderna vaccine. But we do want the individuals vaccinated. The vaccine itself will not have the capability of causing any damage. Now, it's a very important thing to know that the actual what we call the wild type coronavirus, okay, the virus causing COVID-19, it in and of itself can cause a lot of problems, including kidney injury. And so any individual having a kidney problem, an organ problem, if you have a gastrointestinal problem, your physicians are probably going to make sure that you are vaccinated, and so you can have an antibody response, so you cannot hopefully succumb or be negatively impacted with the coronavirus that's out in the community.
Okay, great. So Dr. Sneed, as usual, you gave a lot of valuable information tonight, and we know that this whole COVID situation is extremely dynamic, but there are several people who want to know if the recording will be available and if they can share it, you know, like with their local chapters or at their churches and things of that nature.
You know, I'm going to leave that up to my community partner with Reach Up. Yeah, you know, and Dr. Hill knows very well. I very often I've kind of resisted doing that because I've always felt that if you don't have an expert there to answer a question right then, it kind of leaves a void. And so, you know, I would encourage many of you, and we had a participant reach out recently. Reach out to Reach Up, and we'll be very happy to come back and directly engage with your church or with your organization. I don't have a problem with the recording if it would be available from Dr. Austin. But please keep in mind that when we do that, you know, it's such a changing and such a dynamic moment around COVID-19 that we really feel like we want to have some level of support to give people if indeed they have questions right there at that time, like this evening.
And so what we'll do, Dr. Austin and myself will put our emails in the chat, and certainly you can reach out to us directly because we're continuing to do these workshops. And what we would prefer is that you get the latest, greatest, because as I mentioned in the last week, Dr. Sneed, this is the 4th or 5th workshop plus 2 radio posts and all, and literally every presentation is different. So we will make sure that we provide our contact information, and what we really want to do is arm you all with the latest and greatest information. So that
hey, Dr. Hill?
Yes, sir.
I know we're going to be wrapping up here in just a moment, but
Yes,
there's a question here I want to answer, and this one I really don't get into very often, but I'm very adept at being able to answer. It came from Elizabeth Shelby.
Yes.
Hearing about the impact on not only adults but children. You know, this has been a really particular challenge for many of us. Number one, children overall don't really, and I'm talking younger children, probably less than 15, they really don't have the ACE2 receptor as developed, as developed as we have it in adults. And so, yes, they become infected, and they're much less likely to really develop any of the really serious symptoms. Now, many of the people around the country who have been affected, the children, they typically and usually have fallen into a category, one of the other categories, whether it be overweight and obese or some other chronic condition. And recently we did have a one-year-old up in the Maryland area that passed away. And so that's one of the youngest that we've had anywhere around the country. But children, they have developed a condition it looks much like a condition that we call Kawasaki disease. Okay, and it can be, it's like an inflammatory condition that affects the skin, the joints, it's very painful. It can come weeks or even a month after they have gotten over the infection. It has not been common, but it has been prevalent enough that we have been able to note it not only here in America, but around the world. And so one of the real values that I think we've learned with children going back into the school system has been the simple fact that, number one, children are much better at wearing masks than their adult parents. Number one. Number two, when we put more effort into protecting them in the school environment, we hadn't really seen the outbreak. And then number three, we really can't predict who and what may actually cause that inflammatory condition to occur in children. And so I think that's a very good question. But as of currently and presently, we don't find the really deep cognitive dysfunction that we find in adults, in the way that we talk about that brain fog that many people across the country are going to be walking around with presently and currently.
So also one question Delta Gaddy asked is the vaccine 2 shots or 1 shot? Because she doesn't like shots at all.
Yes. Thank you very much for asking that question. You get a gold star this evening. Number one, every vaccination for COVID-19 will be a 2-shot series. Okay, except there's one in clinical trial. It probably will not come out until the middle of next year from Johnson & Johnson. They are experimenting with a 1-shot, but right now all the rest will be a 2-shot series. And let me prepare everybody. Number one, and I know we're going to be wrapping up here soon, I want to encourage everyone to really think hard about getting the vaccine. I know that we don't have long-term data. I know people traditionally have been very concerned about getting a vaccine. But what I can tell you on a personal level, I plan to get the messenger RNA vaccine as quick. If I had it in my hands, I would inject myself tonight in front of you. When I did the radio show last evening, the bishop that I did the radio show with on a Facebook call, we said we were going to go together and do it on TikTok. Okay, so I want to really help all of you, but there are 2 very important points that you need to know. Number one, when you get the vaccine, it is probably very likely going to cause a few side effects. Okay, we need to make you aware of that. What are the most prevalent side effects? Number one, pain at the site of injection. You're probably going to have that. You will feel like someone punched you in the arm. Number two, you will probably feel fatigued. Number three, you might have some level of headache, and a small number of people have gone on and had a kind of a loose stool or a very mild diarrhea symptom. Now that sounds terrible, I know, but it's actually a very good thing, because that means that your immune system is revving up, and is revving up so rapidly that it's actually drawing energy from you and is putting it into these areas, and you're responding to the antibodies that are now being produced. You need to go through that, be aware of it. In every clinical trial out there, if you take Tylenol, okay, if you take Tylenol, that has taken care of the overwhelming majority of symptoms, number one. And then number two, and most importantly, in all the clinical trials, none of the symptoms seem to last beyond a 48-hour period. The overwhelming majority have been done by a 24-hour period. So that's the first point. The second point, if you get the first shot, you must get the second shot. You will not be conferred full immunity until you get that second shot. Okay, so if you get the first one, you must commit to go back and get the second one. Okay, and they're going to actually mark down your name, and they're going to come back and they're going to expect you to come back and get the second one. Okay, they're going to track. We're tracking that. We need to know. We need to make sure. The bigger problem that we're having right now from a health equity standpoint is that on the one hand, you've got people like me and Dr. McDougall and other people going around saying you cannot leave African Americans, Latinos, Asians, and any other person of color out of getting a vaccine. We want the right to live. But the other problem that we know we're going to have is that we don't want to ship a bunch of the vaccine to an area and then have a large number of people of color choose not to get the vaccine. And so we're kind of dealing with balancing between people not wanting the vaccine, number one, and then on the other hand, we're trying to make sure that we as African Americans and Latinos and other groups are not left out from having the opportunity to protect ourselves against a potentially very deadly virus. So it's a great moment to really think about getting the vaccine. But if you get it, commit to it and go get both of them.
So Dr. Sneed, could you first talk a little bit about the time in between the two injections?
Yeah.
And then secondly, address how we can ensure that communities of color, aren't left out?
Okay, yeah, number one, depending on which vaccine you get, if you get the Pfizer product, which probably is going to get approved and begin shipment next week. Oh, and that's a great point. Remind me to come back to the observation period, Dr. Hill. I want everybody here present to hear it. It will be a 3-week period between the first shot and the second shot. If you wind up getting the other product, the Moderna product, it will be a 4-week period between the initial shot and the second shot. So 3-week time period for the Pfizer product, a 4-week period for the other product. And the majority of them are about a 4-week time difference between the initial shot and the second shot. And what was the second part, Dr. Hill?
How will we ensure that communities of color, aren't left out?
Yeah, so for example, that's why we are fighting very hard to make sure, number one, that essential workers, which many people of color fall into that category, across the spectrum, including teachers, by the way, we're trying to make sure we catapult them up into the higher phases to be able to get the vaccine first, number one. Number two, and to be completely honest, what's going to wind up happening, even though we're having a conversation tonight, and a week from now, you're going to hear about the initial shipment of vaccine. By the time we get enough vaccine in the country, we're probably only going to have about 40 million doses to give across the entire country, meaning only 20 million people are going to get vaccinated initially. Now, what that means for the rest of us, probably me included, is that we're going to have about a 45-day period to observe a lot of people, about 20 million people across the country, long before we have an opportunity to even get vaccinated, because we're just not going to have enough being shipped into the country and around the country to get it quickly enough. And so we're all going to be, I'm kind of deputizing everybody here tonight to become your own clinical researcher, okay, every one of you. And when you do that, when I make that comment to you, when you hear that people in hospitals are getting vaccinated, or when elderly people are getting vaccinated in long-term care facilities, you get a chance to watch what happens. And then if anything is going to unfold that did not, or occur that did not occur in a clinical trial for any reason, you're going to have an opportunity to observe it. And we're going to be observing it simply from a scientific standpoint and a clinical standpoint, but you're going to be able to observe it from your own clinical researcher standpoint. My suspicion will be that many of you are going to find out that, you know what, I think I would rather take the chance, and keep in mind that when we're vaccinating right now, the reason we have to keep it so cold, we're not vaccinating with the stuff from like 40 years ago that had mercury inside of the vaccine to keep for preservatives, okay? There are no preservatives in what we're doing right now. And so, all the vaccine concerns that people have had, beginning 40 years ago, we're not going to have here. We have done away with that. But in exchange for that, now we have to keep it at minus 80 degrees, or we have to keep it at minus 20 degrees. We have to keep it very cold, at least for the initial ones coming out. So I'm just deputizing everybody here. Observe everything. If question everything, you can come back, you can question me, you can go and question your physician, question everybody. But ultimately, the vaccine is doing, in a much safer manner, what the virus wants to do to all of us anyway. And I want to get back out. I haven't been to a restaurant with my wife in about, probably since February. And and it's time for me to take her out. I think she's on tonight. I want to acknowledge her, make sure I can get back in the house this evening. But no, we're ready to get back to living life, and the only way we're going to do it is if we find a way to protect ourselves against the virus.
So Dr. Sneed, you kind of touched on some other concerns. This is a very astute group. But you did want me to remind you about the observation period. So I wanted to
I just shared the observation period. Yeah, everybody's going to observe what happens now, beginning on December 19th. I think that will be the date for the first, Dr. Hill, I had a great conversation with Tampa General today. And we are in full vaccination preparation mode right now. Yeah, Maya and I had a great conversation.
Yeah.
But yeah,
So
go
to
ahead.
your point, some of the questions one are dealing with, let's talk more about the negative reactions that could occur from vaccination. And then the other piece of it has to deal with the fact that it's coming on the news that all the hospitals may not be equipped to actually store the vaccine and all. And I can actually kind of chime in a little bit on that as well in terms of some of the things we're doing at the university. But if you could start out with the negative reaction pieces or side effects of the vaccine a little bit more.
Yeah, well, yeah, I shared the overwhelming number of negative impact that people are probably going to feel. Again, the majority of people, almost everybody will have soreness at the injection site. A number of people probably will have a fever. And along with the fever, that's when people kind of feel a little bit of a chill. We kind of feel that chill feeling, which can be relieved by Tylenol. A number of people are probably going to feel fatigued, and you're probably going to feel a little bit tired and run down. But by the way, it's no different than if you were becoming infected with the actual virus. And then a smaller number of people, not everybody, but a small number of people probably will have some type of stomach upset leading to very mild diarrhea, but that tends to go away pretty quickly, I'm told. And so beyond that, there's not really a lot of other major side effects that I'm aware of that has come out in the clinical trial process. Those are the main ones that people are going to experience, and you will probably feel that.
Okay. So
the storage.
Yes.
Part of the problem with the Pfizer product is that you have to keep it at a minus 80 degree temperature Celsius, which is about 100 degrees Fahrenheit. And that creates a particular problem because many locations around the country, if you happen to be in a more rural area, or if you're not in a big city with a research institution like USF, many locations, your local pharmacy does not have a minus 80 freezer just back there. So the initial product coming out is probably going to be distributed in larger cities that have universities and other large hospitals. When the Moderna product comes out, probably around December 21st, it only requires to be stored in a regular freezer like what you have at your home. And many more locations are going to be able to have that. And so between those two products, we're going to have a lot of product out on the market. The Moderna product is probably going to be shipped to more locations because of the storage requirement. But ultimately, and unfortunately, in the early part, you probably will not have the opportunity to select one or the other. But that's why we really want to educate people about the messenger RNA product, the Moderna product, and the Pfizer product, which is very good. Thank you.
So definitely, and I just wanted to add kind of some of the things that we're doing at the university and the Health Academic Center is a lot of facilities are already getting the freezers and stuff in place, which may require rewiring of electrical plugs and things of that nature to make sure that the vaccines are appropriately stored. And because we do have the flu season upon us as well, we're definitely trying to make sure that that kind of stuff is being inventoried. And I do want to take a moment of pause to remind people that it's so important that we don't forget about the importance of getting vaccination against the flu, because we don't want to have two epidemics and pandemics going on at the same time. So that is going to be really important as well. So there are a lot of institutions, particularly locally, that are already making preparations to deal with it, knowing that, as Dr. Sneed said, everyone will not be able to get vaccinated initially, but a lot of things are already being put in place. We're working with the departments of health as well to certainly make sure that everything is in alignment. So I think Dr. Sneed may have answered several of the other questions, but one of the things that was asked about was what efforts are being put in place in terms of making sure that the African American community is aware of all of this kind of stuff. And so tonight is an example of some of the things that are being done. I know we are setting up meetings with NAACP, 100 Black Men, Links, the Belay, definitely the Cobb Institute, National Medical Association, even the Tuskegee Institute and other entities that are equally vested in the success of the vaccination efforts. But certainly starting out with empowering people first with education so they can make an educational decision about pros and cons, so that we truly try to minimize any kind of problems in that regard. Jeff Randall inquired too about the procedures to make sure, Dr. Sneed, that people are getting both injections. And I wanted to just comment that the departments of health are certainly tracking that and planning and already talking about making sure that there are measures in place for follow-up. And at the university, we're utilizing a lot of our healthcare students in training to help kind of make sure, one, we do follow-up to identify adverse reactions and problems from either treatment or after testing, but certainly we're already having conversations about making sure that people do get those 2 injections and creating programs to make sure that that happens so we don't have fallout that way.
You know, Dr. Hill, there's an important question that came here from Elaine Bryant.
Yes.
I just want, very quickly, I just want to share, you know, you're gonna wind up seeing a big push of advertisement, social media, TV. Part of the problem and challenge is that they don't have organizations like Reach Up in their community. Reach Up is an organization that already has a footprint out in the community. They know a lot of people. And the stark fact of the matter is I couldn't get to enough people to try and answer every question for an hour or so to be able to get to helping people overcome their fear. And so, you know, really what we're trying to do now is empower many of you to be able to go out and say, you know, I've had an opportunity to hear from an individual that was pretty knowledgeable about the vaccine, about coronavirus, about everything, and be able to empower people around you to go out and get vaccinated, or at least get more information and give it a thought. But some of the misinformation that I'm hearing right now, you know, on social media yesterday, almost all around the world, you know, the messenger RNA being able to go in and change your DNA, and Dr. Hill, you know, you and I earlier, you know, I did a call with Nigeria. With people in Nigeria, and that was a big fear they had. You know, they're going to give us something that's going to change our DNA, and you know, it cannot happen. It will not happen. We're not injecting people with anything to track your radio frequency and track your movement. That's not going to happen. Cannot happen. It's just a misinformation campaign that I'm not sure, if you don't have an opportunity to talk to a healthcare professional, that you'll be able to overcome. And so I'm hoping that part of the message will be, please talk to your physician, talk to your pharmacist. Pharmacists are going to be able to administer all over the country beginning in January. So I would encourage all of you to do that.
Okay. Well, I think, Dr. Austin, you have to help me, as well as Sarah, Chantel, definitely. Now, we do have a question from Gloria Wood. Are there any contraindications to the new vaccine in regards to Guillain-Barré syndrome, cardiovascular disease, and/or cancer?
I can't answer Guillain-Barré syndrome, cannot answer that right now. I will tell you that for people who have had that in the past, we probably want to disclose that, because many, I shouldn't say many, there are a small number of people who actually get that when they get the flu vaccine. Mm-hmm. And we're talking about people who have gotten flu vaccines all their life, and then on that one occasion they have a problem, but it's extremely, extremely rare. Mm-hmm. But we want to make sure we have a disclosure, and I don't have the data on Guillain-Barré syndrome, but in terms of cardiovascular and/or cancer, we actually do have data that will be coming out. Again, I believe that data will come out on December 8th. That will come out on December 8th, and I can't wait to get my hands on it. For people that have cardiovascular disease and/or cancer, we do have data on that. We have people in clinical trials around the world. And we have to remember, we had counterparts in South Africa, Brazil, and all throughout Europe that were in clinical trials. And right now, there have been no safety concerns raised for people in those 2 categories, but I'm not sure about Guillain-Barré. That's a great question. Okay.
Well, I would like to thank everybody for their questions. I think that I was able to cover the majority of them. And if we didn't, certainly we want to give a few more minutes, but we do want to respect that everybody's time. And we are just, again, so grateful. Chantel, thank you so much for setting this up. But it took you all to make this program a success. Dr. Sneed, thank you again for being such a wealth of information and all. But I do want to say as a closing note that when you hear them talk about the importance of wearing a mask, of socially distancing, washing your hands, please take that advice very seriously. The vaccination, it's going to take a while, but COVID is going to be around for a while. And so we just, again, attempted to try to educate you tonight. And we do hope that you will be the ambassadors that we know you are. You're already doing great work in the community. So please allow We Care to become your partner. If we can be of any help with you in anything, please don't hesitate to reach out. So as a reminder, we'd like to ask you to please complete the survey and look forward to hearing from us about future programs. And thank you so much for your attention. Again, thank you, Reach Up, for coordinating all of the technological stuff for us. And again, so I'll turn it back over to Mrs. Harrison and wish everyone a safe and enjoyable holiday season if we don't talk to you before then. So
Big shout out to Ms. Harrison.
Yes.
All right. Thank you, guys. A lot of great information. Thank everyone for joining tonight. This was really good. I know that in the chat that they put their information on there. And they've been just so nice and so friendly, especially my sorors, but that's what we do. Just about just giving information and just staying on top of me and making sure that we have this presentation tonight. So I do thank you for that. And I know that they won't mind you emailing them if you guys do have extra questions. But thank you guys. Everyone have a good night. Have a good holiday season. Thank you all. We really appreciate it. Good night.
Good night. Bye-bye.
Thanks.